needed the slope, right? But they gave us the pitch. So jumping back and pitch the slope, 3 inch 24, will go 8 times, right?
Right.
So it's an 8-12 slope. So now we can work the problem. Half you building times 8, 96. Divided by 12 will be 8 feet. Problem. Half the building there, half the span, 12 times 6, is 72, or 6 feet. By the same token, 6 over 24, reduced to 1/4. 4 going 24 to 6. He figured out, back in 1400, what? What he said was, if you have a 90-degree angle, and you have the length and the height, you can figure out what the hypotenuse is by this formula here. He says if you take the A length, multiply it times itself, and B multiply it times itself, and add them together, hit your square root button, that'll give you the hypotenuse of this triangle. So let's do that. Grab your calculator. Let's say this is a 412 slope. So 12 times 12 is 144. Put that in your calculator. 4 times 4 is 16. Add those two numbers together. 160. Now square root.
12.64.
How much?
12.65.
12.654, something like that.
That's 649.
Yeah. That's the length of the hypotenuse. All right, now divide that by 12. Divide that by 12.
1.05.
1.054.
4.
That is the factor of the 412 slope will be 1.054. What this is like I say, all your numbers on your print are flat horizontal numbers. You might find some numbers, vertical numbers or something like that on the cutaway or something along that line of detail. But most of your angles, you have to figure those. Anytime you have a flat horizontal number and you're looking for a dimension on an angle, you've got to add a factor, multiply it times the factor. So for every inch, this is gonna grow 54 thousandths is what it amounts to here. Now this is on the rafter we're fixing to work on. Turn to page 566. 481 in your red book.
Calculators they provide will allow us to derive.
Rafter now. Formula for a rafter is the run plus the overhang times the factor. Now you see, you must include the overhang because it's in the formula here. So this building here is 38 feet wide. What does it say, 38 feet? What length of material would you order for a common rafter for a building 38 feet wide, 1 foot overhang and a roof slope of 412? So we need the run, the formula says the run, so half of that would be 19, 1 foot overhang. So we're working on half the building here, so we're gonna need 1 foot one side. Times the factor of a 412 slope, 21 feet 1 inch. And you order 22 foot piece of lumber. The roof of a house is 48 feet by 32 feet with a 2 foot overhang all the way around and a 312 slope. Square feet is length times the width. But you gotta add the overhang. So the 48 becomes what number?
50,
Huh?
50.
All the way around, 2 feet all the way around.
40 becomes 52.
52 by 36. Oh, you're talking about the whole house, so you have to add both sides. Says well, here it is right there. It says a building is 30 feet by 50 feet. With 1 foot overhang on all 4 sides, and then they gonna want a 612 slope, and they wanna know how many squares, how many bundles, how many rolls of felt. So how many square foot would this be? The 30 and the 50 would become what? 32. All right. So we multiply that, the factor of 612 is 14118, 1,862, or 1,860 square feet. Cover 100 square feet, we'll divide 1,860 by 100, move the decimal 2 places to the left, 18.6 squares. Three bundles to a square, so multiply that number by 3, 55.8 bundles. And then a roll of felt will cover 400 square feet, so 1,860 divided by 400 is 4.65 rolls of felt. It's obvious you can't buy that, but sometimes they just want to know. The same, your building is skewed out some way. And if you don't get that fixed, you're gonna be off until you get B and D. Because you can see corner A is higher than corner B. So it's either B or D is the answer. So how do we figure that? We always take the backside reading, which is from, minus the front side. So 5.9 minus 6.6 is 0.7, times 12.7 feet now, times 12 would be 8.4 inches. So answer B would be correct. Shoot this mile, but they got this hill in here and they can't see from this point to this point, so they're gonna straighten it out and shoot this mile, and he chose 3 different settings here. It doesn't matter how many you do, but he did 3 here, we covered it. You draw your little T like this, you put back side and front side. You come up and take a reading on the back side, and it reads 5, you post that. You turn it, you read 3, that's your front side, you read that, post it. Move your transit down. Do the back side 5, front side 6, you post that. And you're gonna move it one more time, back side 3 and front side 5, you post that. Now you have to label these. This is always benchmark 1, that's elevation. The elevation is sea level, that's from here down. So this would be benchmark 2, 3, and 4. Which this would be 1, 2, 3, and 4. So now we want to read it all the way from benchmark 1 to benchmark 3 or 4. So we draw a line, add them up, and we say 13 minus 14. There's always a minus in here. You're minus 1, 55 minus 1, 54 at this point.
I missed something, honestly, my mind was.
We made 3 readings, right?
Right. So I got the 3 reading part, but what we were trying to figure out, that we still doing, we on number 9?
We were trying to figure out what the elevation is at this point.
At elevation at 54.
Yeah, well, we know, all we know is this is 55. And now we wanna figure the difference here between that and this is gonna be a -1.
Okay.
And the way we get that is we add these numbers up and get two columns, then we say 13 minus 14 is a -1. And take the original elevation minus 1 is 14.
But was that number 9?
No, that's just an example.
I guess I was getting,
Yeah, I see what you're saying. That's just an example up on the top there. For this little example, they wanna know what it is benchmark 3, which is right here. So all you do is you draw a line under benchmark 3, and then you'd add that up. 10 minus 9 would be a +1. So 55 plus 1 is 56 at this point. And if you wanna know what it was right here, 5 minus 3 is a +2, 57 at that point. I don't have it on there, but anyway, 57. But you read that anywhere along there that you shot. But let's label these readings here. This is benchmark 1. First one here will be benchmark 2, 3, 4, 5, and 6. And they want to calculate it at benchmark 6, which is all the way down here to the end. We draw a line under here, we'd add and subtract, we got 30.55 minus 26.84 would be a +3.71. Add it to the original elevation, 193.45 out here. So, do a line under benchmark 4. 16.69 minus 20.31 would be a minus 3.62. 186.12 at this point right here. I can see the old 7th grade math teacher right in my mind's eye right now. What type of architectural symbol does this represent?
Loose insulation.
With. Number
Yeah,
6.
no,
What's the symbol?
What?
Loose insulation.
D? All right, there's a question you need to know on the builders.
I guess B on that would represent your top layer, but
Top.
By the way, there's a couple questions on this loose butt hinge. How far is it from the top of the door to the first hinge?